All right, so we've got properties of matter as the first thing in Unit 4. So three objectives here. So the first one being that we need to be able to recognize the 8 different science and engineering practices and explain how each of those are used, similar to the scientific notation or scientific method, but a little bit different, and helps us really see how science is working and get into lab a lot more. Then contrast temperature and heat in real world terms. And then last, but certainly not least, be able to look at um, different properties of matter. In this video, we're going to look specifically at intensive and extensive properties, and then in the later video, we'll look at physical and chemical properties. So, before we dive in, as you know, pause button, rewind button, so that you can really get everything that you need out of these videos as you're taking your notes. And as you see, you guys are going to be taking notes on page 19 in your notebook. So page 19 in your notebook there. And then if while you guys are doing that, make sure you are taking notes as well. So first, definition of chemistry. So what are you thinking that chemistry is? Go ahead and pause the video and take a second. Think about what you think chemistry is. All right, welcome back. So we've got the definition of chemistry is going to be the study of properties, composition, and structure of all substances, and the changes they go through. So that's the definition. So just to kind of break that down a little bit, properties, that is the different characteristics that substances have. Then composition is what makes them up, the makeup of those substances, and the structure is like how it is formed, the way it's organized of all substances, and then also the changes that they go through. So we're going to break apart some of that today, so you can see how this is kind of central to a lot of things that you guys might go into after high school. So first, scientific method, you guys have heard of this before and studied this in previous classes. So what is it? It's a way to answer questions about the world, and it's really helpful in giving us a logical way to work through that process. You can depend on it and repeat it, and it gives us a system. It's systematic way to gather information. So it is really a great way to learn. The steps of the scientific method start with observation. Then you want to state a question. Sometimes that changes the order a little bit, and then you're going to form a hypothesis, come up with some sort of experiment to test that hypothesis to try to get your answer, state a conclusion based on the evidence, and you see Albert Einstein started with an observation. When he was looking at the data, he realized that things weren't quite lining up. There was kind of a gap in science where the models that were available at the time just didn't really make a lot of sense, specifically looking at large scale things like galaxies. And so he made an observation. He asked a question about how light travels and how it would be impacted by either gravity or movement. He made a hypothesis about what that would look like, and then he did not come up with the experiments or actually perform them, but later on those experiments did confirm the hypothesis that he had about the way that light traveled and how it interacted with gravity and speed. And then as a result, we've come to a conclusion about Einstein's gravity or theory of relativity. So science and engineering practices is kind of a variation on the scientific method. You see that you've got 8 different practices here for science and engineering practices: asking questions, defining problems, plan and carry out investigations, use mathematics and computational thinking, engage in an argument from evidence, develop and use models, analyze and interpret data, construct explanations and design solutions, and last, obtain, evaluate, and communicate information. So really, that is a more relevant way to help us kind of think through the way that science works sometimes. It is more in line with what scientists do on a day-to-day basis in labs, and then looking at labs in this way kind of gives us more opportunities to get into labs. So with that, let's go ahead and dive into the topic of matter a little bit. So what is matter? Matter is anything that has mass and takes up space. Taking up space is another way to look at volume. So states of matter, we've talked about three already. The three main ones, and then we mentioned the fourth. So solid, liquid, gas, and then plasma. We deal mostly with solid, liquid, and gas in chemistry. Those states of matter. Solid has definite shape and definite volume, and it's not easily compressed. Before I move on, let's break down that word compressed. So when you think about the word compressed, the base word there is compress. So if something is going to get compressed, it means that it gets pushed together. And so for a solid, since the particles are so tightly packed together, when you try to compress them, they can't get any closer together. In a liquid, you've got definite volume and no definite shape because it can move around a little bit easier, but it's still not easily compressed because you've got the liquid particles also fairly close together. They're just not in quite an organized pattern, but if you try to push them, they don't have much space to get any closer to each other. A gas, no definite shape and no definite volume. It is easily compressed because if you're thinking about that, where are those gas particles? How close are they? Well, if we're looking at a balloon, they're pretty far apart. So if I push on this, what could probably happen to those gas particles? We could get them closer together. So then you can compress it. You can push those together more closely. A plasma, that's going to be in places like the interior of the sun, and sometimes can be in Earth. It's primarily in lightning. So you see the sun there and some different plasmas like in some form of fire and stuff like that. So we've got, if you're looking at a bottle of water and a rock, go ahead and see if you can get something like that. If I try to squeeze the bottle of water and try to compress that liquid in there, you get it to move a little bit, but it doesn't actually get any more compact, right? And definitely if you're trying to squeeze that rock, it doesn't budge at all. So when you're thinking about compressibility, whether something can compress, you're thinking about, can you push those particles closer together? So why are gases easily compressible and solid and liquids aren't? Well, we talked about that briefly a moment ago. You've got the distance between those particles. So solids have really close particle spacing, so they're really close together and don't have much space, whereas whereas gases have a lot more space, and so they can be pushed together more easily, so they're easily compressible. A vapor is another word for a gas state of a substance. So if you have a liquid or a solid at room temperature and it is in the gas form, then a lot of times we'll call that a vapor, so like water. And that leads us into properties of matter. Properties of matter, like these bamboo chopsticks. What are some of the properties of bamboo that make it a good choice for chopsticks? So if you're thinking, some of the things that you might have come up with are um, that you don't really have much of an odor, which helps because it doesn't impact the way that you are tasting. So it doesn't really have any taste to it. It's hard, it's rigid, so it's not going to bend whenever you're trying to use it. And then it's easy to split, so it's easy to make into those small chopstick shapes. It also is heat resistant, so if your food is hot, that's something that you'd want to have a property of. And you can have properties of matter help us classify where they go in relation to other types of matter. So some examples of property are things like density, mass, volume, color, hardness. There are tons more types of matter, but these are just a few. If you remember back to our 3 objectives, we also needed to be able to talk about extensive and intensive properties. So we need to be able to describe matter and be able to tell if a property is an extensive property or an intensive property. So let's dive into that for a moment. Extensive properties are ones that depend on the amount of matter. They depend on the amount of matter. So think about some examples, some properties that you think depend on how much matter, how much of the substance is there. Pause the video, think if you can come up with some extensive properties, things that depend on how much matter is there. So one example is going to be mass. Definitely if you've got twice as much of a substance, what happens to the mass? Yeah, it doubles. So mass is one of the most common extensive properties that we deal with in science. Volume, another big one. If you double how much of a substance you have, then the volume is going to double. Intensive properties instead are things that, like this bowling ball, they depend only on the type of matter. Only on the type of matter, and it doesn't matter at all how much you've got. So you can have a bowling ball made of either polyester or polyurethane, and it doesn't matter the size of the bowling ball. Hardness is going to be the same exact hardness no matter what size the bowling ball is. Can you think of some other properties that are intensive, that depend only on the matter that it's looking at? So another one is density. The other most common intensive property is density, because no matter what amount of a substance you've got, it's going to always have the same density. So summary, we've got the definition of science, definitions of chemistry, the scientific method, and science engineering practices. Need to be able to know the different steps of the scientific method and the 8 science and engineering practices. Definition of matter, the properties of matter, and the different properties of each of the states of matter or phases of matter. And extensive versus intensive property, need to be able to know what the difference between those are, as well as know and be able to recognize if a property is extensive or intensive. So in reflection, did you pause the video as you guys were going through that? As you were going through the video, making sure that you were taking notes. Again, you guys are awesome with that already. Just a quick reminder, if you had forgotten to, you'll want to go back and take those notes, make sure that you go through and take down anything that you are going to need so that you can make notes of things that you might need to ask me in class. And again, thank you guys for being awesome. Go ahead and tackle worksheet 1 and let me know what questions you've got. Thank you guys.